All right, this is a little bit of an explanation and demo of Conway's Game of Life assignment. If you're unfamiliar with what Conway's Game of Life is, you can click this link and this will give you an example. So basically, you've got a grid, and every cell in the grid can either be alive or dead, and the alive ones here are represented by being colored yellow. And if we click Start, it has a few rules that each cell follows in order to either die, remain living, or come to life. And I'm not going to really go over what those details are because I just want you to see what happens. But if I just click Start with this default arrangement, we have what's called a spaceship. Let's see what Wikipedia has to say about those things. So if you wanted to try out a different spaceship, we've got 4 different spaceships you can create using one of these arrangements, or you can create an oscillator using one of those arrangements, or still life. You can kind of tell what the difference is. Still lifes don't change at all. Oscillators are a repeating pattern. Sometimes it takes more than 2 or 3 frames to repeat, but they do all repeat. The spaceships are defined by the characteristic of moving across the screen. Okay, so if you wanted, you could of course change this and see how that affects things. If we just add a few things here and then click Start. Oh, so part of the rules is that if it doesn't have any neighbors, it just disappears in the next version or the next iteration. So let's give a few more, or color a few more of these and see how that changes things. Okay. It's morphing into something new. That's exciting. Anyway, they call this a 0-player game because once you've started it, you really don't have to do anything. You can kind of just sit back and watch it. Oh, it turned into a still life there, so it's not going to change anymore. And that turned into an oscillator down there, so it's just repeating. Anyway, so that's what the Game of Life is. Let's go back to the assignment. So the requirements are to be able to load an arrangement of ones and zeros, and that file could look something like this. So I have one of the still lifes set up. In fact, I've got 3 different testing configurations you can use. I've got the still life right here. You can copy and paste this into a text file. I've got a big oscillator configuration set up here that you can just copy and paste. Or I've got one of the spaceships you can use. Anyway, so you load in that file, and this is what it looks like when you run it. Let me just test. So the still life shouldn't really do much. As you can see, it just stays there. Let's try one of the other ones. Let's try the spaceship. So copy that into my life.txt file. Save it. And I'm going to have to stop that program because it just repeats forever. So I stop it and then I rerun it. So here's the spaceship. You can see it moves down to the bottom right corner. And if you wanted to see it move to a different corner, you'd just have to rotate it, the initial configuration. Eventually it reaches the bottom and it gets to that still life configuration, so it's not going to change anymore. Let's try the most exciting one. Copy and paste that in. Test this. Goes through, my computer's lagging a little bit to display it, but it goes through 15 different periods, through 15 different iterations before it repeats the cycle. Anyway, so that's the goal here.